Dear friends, good morning, good afternoon, and good evening. We are pleased to meet you again at another exciting Mindray new product launch. As you know, Mindray provides a complete range of hematology analysis solutions tailored to all laboratories, from 3-part diff to 5-part diff analyzers, and from cellular analysis line to digital cell morphology analyzers. We currently deliver our hematology solutions to customers in over 190 countries. Moreover, our products and solutions have been recognized by top medical institutions worldwide. To maintain our fast-paced growth, we have established a dedicated team of more than 300 scientists and engineers for hematology. Each year, we invest 10% of our sales revenue in R&D and allocate 50% of our budget to the development of new products, and 30% to the upgrade of the existing products, and finally, 20% to the development of new technologies. Having gained worldwide recognition, Mindray's hematology solutions now hold the #1 market share position in China and #2 in the world. With our continuous investment in R&D, our engineers are well equipped to advance medical technologies to meet the evolving needs of our customers. Today, we are excited to launch the BC-700 series hematology analyzers, our newest breakthrough innovation. We strive to turn our core technology of 3D SF cube analysis into reliable results that can benefit more labs worldwide. Powered by our new PLT detection technology, the BC-700 series can address challenges that were previously inadequately met by conventional hematology analyzers. It even allows analyzing PLT in hemolytic samples, offering you a complete solution for PLT analysis. Now, as a world-leading diagnostic company, Mindray is committed to developing cutting-edge technologies and customer-oriented solutions. After a thorough survey in more than 30 countries and regions, we found that there is a demand for all-in-one testing for CBC and ESR. Therefore, we have incorporated CBC and ESR analysis in the BC-700 series to help improve as well as expand your capabilities. Now, we built all these features and innovations into a user-friendly and intuitive design, which has won the IF 2021 Design Award from one of the most prestigious institutions in the world based in Germany. Now, let's witness this exciting moment together. Thank you.
Why are you looking so frustrated?
The result for these cases that do not match well with the patient's symptoms. The doctor asked me to analyze the samples all over again on the hematology analyzer, and I found that the results were exactly in the same as the last time.
So what did you do next?
I looked in the microscope and I found that there was an expected increase in the number of eosinophils in one sample, which also contained parasites. For another sample, I found that there were very few abnormal white blood cells in it, so I suspected the patient had chronic leukemia.
Oh, it sounds really bad. How come the analyzer didn't give you any flags on it?
I should report this to our manager. It is time for an upgrade.
Although WBCs only account for 1% of the total cell population, accurate WBC results are always the most important request of our customers. This is because WBCs are a part of our immune system to fight against foreign invaders. If they are massively and immoderately distributed inside our body, we would call this cancer. WBCs can be easily spotted when cancer becomes a reality. However, when a patient with no symptoms and a normal CBC and diff report, massive change has already occurred in his body. We know that the number of abnormal and immature WBCs can be very low during the onset of cancer, and no differential results can be obtained at this stage. If the sensitivity of your hematology is not enough, the patient might probably miss the best time for treatment. In terms of the WBC differential count, various technologies have been invented for accurate detection of blood cells, such as chemical staining scatter light, especially for WBC and RET detection. WBCs can be divided into 5 categories: lymphocytes, monocytes, neutrophils, eosinophils, and basophils. Analyzing all these types of normal WBCs will provide a great deal of useful information for the clinical diagnosis of diseases. However, does the current solution meet the clinician's request? Under the influence of certain diseases, the peripheral blood may contain various abnormal cells, such as atypical lymphocytes, immature cells, etc. So it's very important that the hematology analyzer has the capability of detecting abnormal cells and immature cells. Our BC-700 series hematology analyzer adopts the 3D SF-cube fluorescent staining technology, and it's built from the same platform as our BC-6000 series. In 3D SF-cube technology, the intensity of the forward scatter lights reflects the sizes of the cells. The intensity of the side scatter lights reflects the intracellular granularity of the cells, and the intensity of the fluorescent signal reflects the nucleic content of the cells. A comprehensive 3D scattergram will be generated for a better illustration of the cell clusters, which allows us to distinguish cells more easily and provide more reliable results to the doctor. With the help of the 3D SF-cube technology, the analyzer can provide not only reliable WBC differential results for normal samples, but also accurate abnormal cell detection results for WBCs, RBCs, and PLTs. It has an excellent ability to distinguish immature granulocytes and high fluorescent cells. NRBCs are analyzed in every single sample, and the WBC results are automatically corrected. Immature platelet fraction and immature RETs can be measured for cells production in bone marrow. We can even differentiate the maturity of RETs. Besides, when the WBC count is low, the result you might fail to get previously, you may need to make blood smear and review it manually, which can be tedious. But now, by increasing the analysis time by 3 times in the diff channel, the BC-700 series will give you a WBC result with a differential count. Samples with a low platelet count will be analyzed for a length of time 5 times longer than before. All these parameters and analysis modes are valuable for early diagnosis, effective risk assessment, and therapy monitoring of diseases. We hope to bring everyone a new experience with this incredible technology.
Is this for ESR testing?
Yeah, we are doing it manually at the moment.
And how many samples do you have per day?
It's around 20% of our current hematology samples. It depends on the doctor, but we have quite a lot of orders still.
This means you have to get a test tube after the routine CBC test and then perform the ESR test. It sounds tedious.
And it takes a lot of time to wait for the result, and almost more than 1 hour for each sample.
A lot of ESR analyzers on the market can give you a fast result. Why don't you just upgrade it?
Well, our main hospital has been using it since last year, but we are not satisfied with the result. And we don't have as many samples as there, so we just keep the manual method right here.
ESR is an acute phase reactant, which is a marker for inflammation. When inflammation occurs, the ESR value increases. Because ESR is correlated with diseases, it can be used as a predictor of serious underlying diseases, most often infection, collagen vascular diseases, or metastatic tumor. After the diagnosis, we will use the ESR value to monitor the status of the patient, as it is correlated with response to therapy. In asymptomatic persons with a markedly elevated ESR value, a minimal number of tests usually reveal the cause. Traditionally, we will perform the CBC test and then perform the ESR test, if needed, in a test tube, and the result will be available after an hour. Now, the BC-700 series offers you an all-in-one solution. It allows performing CBC and ESR together in one test tube, which helps to streamline the workflow and save your costs. We can take less blood from the patients, especially for the pediatric and elderly patients. Additionally, technicians do not have to wait for an hour to get the result. It takes only 1 minute and 30 seconds to get the result for both CBC and ESR tests. The second most important concern would be the reliability of results. Studies have shown that the ESR results from the BC-700 series correlated well with those from the traditional Westergram method. Do you wonder how we did it? Actually, we detected the RBC aggregation process. We detected the aggregation degree and the aggregation speed with photometry. Moreover, our analyzer uses the same QC and calibrator as the BC-6000 series, and even has better repeatability and anti-interference capability compared with the manual methods.
Oh, I have to run another blood smear again.
What happened?
Is the PLT. The PLT value is 120. I checked the histogram. The size distribution curve started on the baseline and didn't end there. The curve didn't match the 20% line twice, and there was no right shift, but it seemed that there was a second peak.
The detection result was probably interfered by small RBCs or fragmented RBCs. This is elimination of the impedance method.
Are there any other technologies to count them?
Of course, but visually you have to get a new analyzer first.
Besides white cells, platelets are also main concerns in the hematology market. Here, we boldly put forward a new idea: optical platelet in every CT test. To explain more about this idea, let's go back and talk about platelet first. As is known to all, platelets are a component in the blood. They will come in reactions to bleeding from the blood vessel injuries, thereby initiating a blood clot. If the platelet count is low, for example, 20 to 30, the patient may have a tendency to beat seriously, or even beat simultaneously. If the platelet counting is high, it will cause the patient to unnecessarily develop abnormal clouds. What if you report the platelet result falsely? If the result is falsely low, the patient may be provided with a blood which is not needed. Some may react in various ways to blood transfusions. Some may take the wrong medicine, and some may even suffer from the bone marrow test. And if the result is falsely high, the patient will miss the best time for blood transfusions, and it may lead to wrong diagnosis, since the platelet can be evaluated as a reaction to something else that is going on. A reliable method to evaluate reliable platelet counts is always important and always a challenge for us. Many studies and past experience have shown that analyzers that use traditional impedance methods often fail to deliver reliable platelet results, especially when they are used to count platelets with small red cells and fragmented red cells. Optical platelet counting is a good choice to solve these problems. However, these methods, in most cases, will require additional regions or channels, which will raise costs to our customers. What if we offer you a new method for reliable platelet countings without extra costs in every CBC and DIF test? Now, with the help of SAQ 3D technologies, we have developed many useful parameters. And this time, we pushed ourselves to the limit of innovations by introducing a new parameter, PLT-H. Let's see the performance. When compared with the impedance methods, for example, in the case of large platelets or interference such as red cell fragments and small red cells, we can definitely give you a reliable result. When compared with our optical platelet, we also show very good consistency. Quite impressive, right? How did we achieve it? What does the H in PLT-H stand for? Our R&D team will show you more about it next.
Thank you, Ari, Sally, and Shuning for your presentation on the BC-700 series hematology analyzers. The BC-700 series has many innovative features. To meet our customers' needs in different clinical applications, Mindray has invested heavily in R&D to develop new technologies. This year, we released an integrated analyzer for ESR and a new platelet solution, PLT-H. So, how did we achieve all these new breakthroughs? Let's give a warm welcome to Mr. Zheng and Mr. Xun from Mindray R&D team to share how we have successfully implemented these technologies. Hi, Mr. Zheng. And as Ari mentioned earlier, getting an accurate platelet count is critical for disease diagnosis and treatment. And there are so many different PLT counting methodologies on the market. Mindray has developed our patented PLT deaggregation technology to solve the PLT clone problem. Why do you think we need another PLT counting solution, PLT-H, and what additional problems can it solve?
Well, that's a good question. The traditional impedance method is susceptible to the interference of small RBCs, RBC fragments, large PLTs, and PLT aggregations. And the optical method can completely address the above problems, but it involves high costs and requires new independent physical channels and additional regions. Therefore, we need a zero-cost, high-accuracy PLT counting method, which is our PLT-H.
Wow, a zero-cost but highly accurate counting method. That's cool. I wonder how you made that happen. I mean, it can be really tricky to deliver accurate PLT-H results at a very low cost.
The traditional impedance method is primarily subject to the interference of RBCs in detecting PLTs. We can deduce that if red blood cells can be niced, PLT will not be affected by this interference. Mindray's commonly used hematological agent, LD-NICE, can dissolve red blood cells.
So it means that the PLT-H is generated only in the DIF channel, right?
Yes. and it uses the same reagent as the diff channel.
What a cost-effective solution. But where can I find PLTH from the scannogram?
If we look at the diff channel, the next RBCs and PLT particles are located in the ghost area of the scatter ground.
Ghost area?
Yes. By designing a high-sensitive optical system, we can detect all particles in the ghost area. Based on extensive clinical data studies, we have reached the following findings. The particles in the ghost area come in three parts: large PLTs, which are not interfered by RBCs; small PLTs, which overlap with the next fragments and are indistinguishable from the later; and IETs, which have a higher fluorescence signal intensity than RBCs. From the above, we know all these three parts are in the diff channel. What did you see?
It looks like large PLTs are not interfered by RBCs, but it is difficult to distinguish the small PLTs from RBC fragments.
Yes. We have verified through a large number of clinical samples that PLTs larger than 7.5 femtoliter are free from interference in the diff channel. As shown in the figure below, the total count of PLTs larger than 7.5 femtoliter detected in the diff channel correlates well with the reference value. The PLT volume distribution curve for PLTs larger than 7.5 femtoliter is consistent with the volume reference curve. Therefore, we can conclude that the diff channel can accurately detect PLTs larger than 7.5 femtoliter. Now, let's get back to the impedance channel. As revealed by several clinical data studies, the interference of RBCs falls primarily in PLTs larger than 10 femtoliter, which can be accurately detected by the diff channel. Therefore, the diff channel can be combined with the impedance channel for eliminating the interference of PLTs.
Thank you so much for such a detailed explanation. The solution is really innovative and it has uniquely combined the advantages of the diff channel and the impedance channel. We know PLTH is a key technology in the BC-700 series. Well, there is also another key technology, integrated ESR and species tests, which has been long expanded. So, Mr. Xun, as far as I know, CBC and CRP hematology analyzers have been quite popular in the Chinese market. However, the newly launched BC-700 series combines CBC and ESR tests in a single solution. Why did we choose to integrate both tests together?
Delivering integrated hematology analysis solutions is an important part of our technical effort toward meeting customers' needs. In China, we have developed a CBC and CRP hematology analyzer in order to guide the rational use of antibiotics in clinical practice. The analyzer has been a hit in the Chinese market since its launch. However, from our survey into the global market, we found that the orders for both CBC and ESR are placed at a high ratio, even over 80% in some regions. We noticed that the CBC and ESR tests often take place in the same department, but there had yet to be a hematology analyzer that could perform these two tests simultaneously. And this is why we integrated CBC and ESR tests in a single hematology analyzer.
We are glad to see a product that can truly satisfy global customers' needs to simplify the workflow. For the test time, we know that it takes 60 minutes to complete a traditional ESR test, and our new product can complete both CBC and ESR tests within a mere 1 minute and 30 seconds. How is that possible?
The BC-700 series can predict ESR by detecting the aggregation degree and the speed of RBCs in a short period of time, which ensures a high detection speed. You guys know how to perform an ESR test, right?
The RBC sedimentation process can be divided into 3 stages: aggregation, sedimentation, and packing. The sedimentation starts after the RBCs aggregate and form clusters. Traditional ESR analyzers based on the Westground method or modified Westground method need to detect the sedimentation distance of the RBCs directly. This per sample means that the detection will take a longer time. Is that right, Mr. Xu?
Yes, rapid ESR analyzers on the market today predict ESR by merely detecting the RBC aggregation degree within a few seconds. Their detection speed is fast, but the accuracy is unsatisfactory. By observing and analyzing the RBC sedimentation process, we found that besides the aggregation degree of RBCs, its speed is also a key factor affecting the ESR. Both of them determine when the sedimentation starts and how fast it occurs, respectively, and jointly determine the ESR value. Therefore, with the BC-700 series, we obtain the aggregation degree and speed of RBCs by detecting the aggregation process and established an ESR prediction model based on the aggregation degree and speed. Since the aggregation speed of RBCs is as important as the degree of aggregation for the ESR value, we take several measures to ensure the accurate detection of the aggregation speed. First, we precisely control the flow at which and for how many times the RBCs are deaggregated to ensure that they are deaggregated to a monodispersed state. Meanwhile, by increasing the rigidity of the test tube, the deaggregation can be stopped quickly to ensure the entire aggregation process, starting from the moment they are monodispersed, can be detected. The entire detection process is conducted in constant temperature detection components, which prevents the results from being affected by the ambient temperature.
Indeed, this is a very advanced technology, and I guess it must have taken you and the team a long time to develop it. Well, do we have any evaluation reports or other materials proving its superiority?
Yes, of course. We have worked with several hospitals to evaluate the ESR testing performance of the BC-700 series in 30 departments, including rheumatology and hematology, in response to 300 diseases. The clinical results have shown that the correlation of the ESR results from the BC-700 series with those from the traditional Western method is higher than 0.9, much superior to other rapid ESR analyzers on the market.
I'm really looking forward to the BC-700 series. From this brief 10-minute conversation, we know that the BC-700 series has achieved a technological leap by overcoming several technological limitations. We hope that this analyzer can benefit our global customers and contribute its due share to human health. Thank you very much for your great sharing. Next, let's look at how some well-known professors view the BC-700 series. Thank you very much.
Hello everyone, I am Dr. Kunal Sehgal from Sehgal Path Lab, Mumbai, India, and I am very glad to evaluate the BC-720 cell analyzer in our lab. Hematology analyzer product differentiation is often accomplished by different methodologies or by adding newer parameters. And this time, Mindray have happily surprised me by integrating the CBC and the ESR test. The Mindray BC-700 series, to my knowledge, is one of the first 5-part hematology analyzers to have integrated the CBC and the ESR test. The BC-700 series analyzers take only 1.5 minutes to do the combined CBC-ESR test and use only a minuscule volume of 116 microliters. This could be extremely useful in a private pathology practice like ours. Not only it reduces the turnaround time for the report, also increases the work efficiency and the staff time required to do a simple test like ESR. I really look forward to evaluating the Mindray BC-720 analyzer in the lab and utilizing it to its full potential. Thank you.
Witam, nazywam się Ewa Sikora, jestem diagnostą laboratoryjnym pracującym na co dzień w szpitalu pediatrycznym. Przez okres 3 tygodni miałam możliwość przetestowania aparatu hematologicznego firmy Mindray. Jeżeli chodzi o pracę w szpitalu pediatrycznym, to bardzo dobrze sobie radził z małymi objętościami, pobieraniem krwi głośniczkowej. Również w pracy rutynowej puszczania serii oznaczeń dobrze sobie radzi z pobieraniem próbek. Przez okres testowania aparat pracował bez usterek, bez awarii, co jest również bezcenne. Także dziękuję za uwagę.
Dzień dobry. Do testowania otrzymaliśmy aparat BC-760CS. Ponieważ mamy go dopiero od 2 dni, nie mamy jeszcze pełnych danych o możliwościach tego aparatu, Natomiast to, co możemy powiedzieć, to to, że jest mały, kompaktowy, intuicyjny, ma 37 parametrów raportowalnych i dodatkowe parametry RUO. Co jest ciekawe, to, że można wykonywać OB wraz z morfologią z jednej probówki. Dziękuję.
Today is a memorable day for all of us. We here at Mindray are taking another huge step towards fulfilling our mission, healthcare within reach. When you compare BC-700 series to the previous BC-5000 series, you see remarkable upgrades, as well as groundbreaking innovations. These are by far the most powerful, innovative, and compact all-in-one hematology analyzers in the market. We completely redefined what a hematology analyzer for small to medium-sized labs can be. With the launch of BC-700 series, you can have the advanced SF-Cube analysis technology with patented fluorescence dye for accurate and reliable results, all in a compact analyzer suitable for your space and sample volume. In addition, BC-700 series is the first hematology solution that combines 5-part diff with ESR analysis, which significantly improves the efficiency of hematology testing with just one test tube. Last but not least, Mindray has created an innovative PLT-H parameter to give you more advanced diagnostic tools. We designed and built this for you because we are committed to empowering all labs with better technology and more accurate results. And that commitment is what drives us here at Mindray. We believe all labs matter, and while other big-name manufacturers only focus on the needs of large labs, we are different because we listen to the needs of all labs, no matter your size, location, or sample volume. We understand that your needs are important, whether you are a small but growing private lab in India, or a public hospital in Egypt, or a medium-sized lab in Colombia, or a growing chain lab in Indonesia. You need solutions that empower trust and accurate results. This is what drives us to engineer solutions that go above and beyond your requirements. In closing, I'd like to take this opportunity to thank everyone here at Mindray for their efforts in making this happen. Thank you so much for joining us today. Stay safe, and we wish you a healthy and prosperous 2022. Thank you.